Right, question 5. Now, it doesn't say detailed reasoning, but it does say show that. And if you have a show that question, then you are going to have to go into detail with this. So it's another way of saying you show detailed reasoning. It's a way of, you've got to do all the steps. One thing I want to get out of the way before we get any further with this, the question has a surd on the bottom. The answer has a surd on the top. So we're probably going to have to rationalise the denominator somewhere. It's a show that question, so we're going to have to show that we've rationalised the denominator. And that's where lots of people came unstuck with this one. So, right, how do we do trapezium rule? 2 strips. I hate ones with 2 strips. So the x values are going to be 0, 2, and 4. The y value is 1 over 2 plus root x. So that is going to be 1 over 2. 1 over 2 plus root 2. And 1 over 2 plus root 4. So that's a quarter. So when we do the trapezium rule, the step size is 2. When we do the trapezium rule, the integral from 0 to 4, 1 over 2 plus root x dx, is going to be approximately equal to 1/2 times h. And then it's the first plus the last. The first plus the last plus twice the terms in the middle. Okay, all going very well. I'm doing a good job with this answer. So there, I've got 2 marks for getting that far. One of the marks was for h. One of the marks is for getting the correct use of the formula with exact y values in it. Now comes the problem that we've got this 1 over 2 plus root 2 in our fraction. So let's see where we go with that. That's approximately equal to 3/4 plus 2 over 2 plus root 2. And many of you might feel that is equivalent to the answer. You could just write, if you put that into your calculator, it gives you the same exact answer, so why not just say that equals what we want it to be. But this was a show that question. So we're going to have to go from this point here to our end point, showing what we're doing. So that, the next step would be to say that is 2 over 2 plus root 2 times 2 minus root 2 over 2 minus root 2. We would have to rationalise the denominator to get 3/4 plus 4 minus 2 root 2. That's 2 times 2 and 2 times root 2. And this would be 4 take away 2. So divided by 2. Have I done that right? So, what have we got out of this? We've got 3/4 plus 2, because 4 over 2 is 2, take away 2 root 2 over 2. And now we can say that is 11 over 4 minus root 2 as required. And I'm sorry about this, but they did demand seeing a method for rationalising the denominator leading to the correct answer. And you, in order to get the A mark at the end, you had to have at least one step of working out that took you from the answer of your trapezium rule to the answer that was given. You couldn't just put an equals without showing some manipulation of that irrational denominator. I think there's a real danger that I might have got caught out with that myself in doing that question, because that's it feels harsh, that, doesn't it? Oh, I've not got the page there. There we go. Right. The question went on. It then said, use the substitution. Now, we didn't do this terribly well either. Use the substitution x equals u squared to find the exact value of the integral. So if x equals u squared, we need to know dx by du would be 2u. So dx is 2u du. The integral was the integral from 0 to 4 of 1 over 2 plus root x dx. We need to change the limits as well as changing the variable. So if x equals 0, u equals 0. If x equals 4, u must be 2, because 2 squared gives us 4. So the integral becomes the integral from 0 to 2 of 1 over 2 plus u, because root x is u, and dx becomes 2u du. Now I think what was a little bit unkind about this question,
do you get marks for converting?
if you've converted it fully, then you do get marks for converting it.
How does it work?
So
That's all.
you converted the limits,
Yes, the limits.
not just the limits on their own. So you need to have got to that integral point in order to get the mark. 2u over 2 plus u du is what we're doing. The problem with that is it's I don't think that's an obvious integral on its own. It's one that you can do in a couple of ways. So you could do I think probably I might do a what might I do? Something like let t equal 2 plus u. So dt by du equals 1. So dt equals u. So if I now do another substitution, the integral becomes the integral of, well 2u is twice t minus 2. And 2 plus u is t. dt equals du. Do I want to change the limits as well? When u is 0, t is 2, and when u is 2, t is 4. So the integral has now become that. It's a bit of a monster, isn't it? So it's the integral from 2 to 4 of 2t over t minus 4 over t dt. If I split up that fraction, so it's the integral from 2 to 4 of 2 take away 4 over t. If I do that integral, I get 2t minus 4 ln t between 2 and 4, which gives me 8 minus 4 ln 4. Take away 4 plus 4 ln 2, and I end up with, what do I end up with? 4 and then there's a number of ways that I can tidy this up. It just wanted an exact value of it, didn't it? So what am I to do with this? I've got well, I think actually I'd get the mark for where I am with this, but I might write 4 ln 2 minus ln 4 if I do that. So that is 4 plus 4 ln a half.
Why do you change from the limits?
I've changed the limits because I've done a substitution. So when u is 0, t would be 2. When u is 2, t would be 4. So I needed to change the limits. The problem, the nasty thing wasn't it, that having done the substitution, you didn't automatically get a lovely integral that was trivial to solve. That's not the answer that they actually give. They give the answer as being 4 minus 4 ln 2, because of course a half is 2 to the minus 1, so you rearrange that. But that answer is going to be acceptable. Horrible, isn't it? The other way, if you want it, the other way of doing that kind of integral is to say, if we've got the integral of 2u over 2 plus u, then what you could do with that is you could imagine the 2 being outside of it. And then think about writing that top line as being 2 plus u minus 2 over 2 plus u. Can you see what we've done with that? All I've done on the top line is I've added a 2 and taken it away, so I've not changed the top line, it's still the same thing. And then I can split up the fraction, so it is 2 plus u over 2 plus u, take away 2 over 2 plus u, and that gives us 2 lots of, well, that's 1. If you integrate 1, you get u, and if you integrate 2 over 2 plus u, you get 2 minus 2 ln 2 plus u. And that leads you to the same answer. Once you put the limits of 0 and 2 in, it leads you to that same point. So you could have done it without another substitution, but having done all that hard work of the substitution, it was a bit of a mean integral to leave you with, isn't it? So there you go. Using your answers to part 1 and 2 show that that thing is true. I wonder whether you could have redeemed the marks in part 3 if you'd thought about this. So you could have used your calculator to find the exact value of 1 over 2 plus x. Would it give you? It wouldn't give you an exact value, would it? So you couldn't. So anyway, forget that. Part 3 involves you saying that 11 over 4 minus root 2 is approximately equal to 4 plus 4 ln a half. The question has talked about natural log of 2 in this, hasn't it? So at this point, if I haven't already, I am thinking I need to get that in terms of natural log of 2. And because a half is 2 to the minus 1, I can write it like that. And now I just need to rearrange this to see if I can get the required answer. So 4 ln 2 is approximately equal to 4, take away 11 quarters plus root 2. If I rearrange that equation, 4 ln 2 is approximately equal to, what is that, 5 over 4? Plus root 2. If I divide by the 4, ln 2 is 5/16 plus root 2 over 4, and it said k plus root 2 over 4. So there we go. It said write it in the form or show that that's equal to that. You could have then put a little aside to say k equals 5/16, but you didn't have to. There we go. And that's maths.